Hello everyone. So today we're going to work on two things. We're going to work on what is called the discriminant, and then we're going to work on writing equations based on, hey, here are the solutions. What are the equation that got us here? All right, so we're going to use the discriminant and determine the number of solutions and the type of solutions. Now, number of solutions means it could be 0, 1, or 2, and the types of solutions could be real, either rational or irrational. There could be one rational solution. There could be imaginary or the I solutions. So that's what we want to know. And then we're going to write a quadratic given the equation. We probably could write a polynomial, meaning x to the third or higher. So I know the answers. What's the polynomial that got us there? So let's start with the discriminant. The discriminant is in the quadratic formula, x equals negative b plus or minus b squared, square root of b squared minus 4ac all over 2a, that the b squared minus 4ac part, the guy underneath the radical, is called the discriminant. So he determines the type of solution. So the solution to this kind of like comes in like three different parts. You can have a b squared minus 4ac. That is a positive number, okay, greater than 0, so that means a positive answer. And the positive answers could be rational or irrational. You can have a b squared minus 4ac that's equal to 0. That means there's one answer, and that answer is going to be rational. And there's a b squared minus 4ac that could be less than 0, which means that we have a negative answer, which means our answer is with I. We call those imaginaries. Okay? All right, so let's see what we have. This is a little chart that has all that information for us, so we don't have to rewrite it. So when we're equal to 0, we're going to have one solution. It just happens to be repeated, and he's rational, meaning like fractions and decimals and things like that. So like, for example, here, the number underneath the square root sign was 0. So that means we have one rational solution that happens to be repeated twice. If he's positive, so let's change this color up. Let's go with the mint. Okay, so b squared minus 4ac is a positive number. There are two possibilities. If he's a perfect square, like 9 and 16 and 64, and we're able to like take the square root, there are two rational solutions, okay? So meaning we're going to get two fractions as solutions. And we can also get like 4 over 1 and things like that, and that also works. And those are considered rationals, okay? And you can also get not a perfect square, right? Which means we're going to get two irrational solutions, meaning like the square root of 10 or the square root of 17, things like that, that we're not going to be able to do anything with and just leave it as the square root of 17. And the last possibility is if he's negative. Okay, meaning that there are imaginary solutions. This is the i's. See here, i's. Okay, so this one, okay, had the plus or minus, and then here's our rational, and then this guy only had one solution. Okay? All right, so our goal is to figure out how many solutions there are and whether they're going to be imaginary with the i's, whether they're going to be rational or irrational. Okay, so let's take a look at our problems. All right, so here we have 9x squared minus 12x plus 4. Again, we're looking for a, b, and c. So a, b, and c. So on the side here, a is 9. B is negative 12, and C is 4. Now, after a while, you probably don't need to do that, but I always feel like it's a good idea to who's A, who's B, who's C, so we don't like put the number in the wrong spot. So here's our discriminant, b squared minus 4ac. Okay, so we're going to go negative 12 squared minus 4. A is 9, C is 4. Okay, so 144. All right, I don't remember. See, this time I remember to pull up my calculator. So 4 times 9 times 4, 144. So 144, or we're going to get 0. Now, since our answer is 0, that means there's one rational solution. And it's like repeated, okay? But I'm good with one rational solution. All right, let's try this one. Again, very helpful to say who's A, who's B, who's C. So A is 1, B is 5, and C is 8. Okay, so we're using B squared minus 4AC. Okay, so 5 squared minus 4, A is 1, C is 8. So this is going to be 25 minus 32. So I believe that's negative 7. Okay, so he's negative, which means that we have two imaginary or i's solutions. Okay, now remember when I talk about imaginary, that means that the square root involves a negative number, so that's an I. Remember we talked about that. Okay. All right, let's try this guy over here. Again, A, B, and C. Okay, so B squared minus 4AC. Notice this time I didn't write it on the side. 7 squared minus 4. A is 2, C is negative 3. Okay, so this is going to be 49 minus, that's going to be 8 times 3 is 24. Negative 24. Okay, so that's plus plus, so that's square root of 73. Okay, so 73 is not a perfect square. So we're going to get two irrational solutions. Okay, so how do we want to write that? Two irrational solutions. There we go. All right, let's do one more. Okay, so B squared minus 4AC. Okay, so negative 9 squared minus 4. A is 3, C is 2. So this is going to be 81 minus, that's 12 times 2 is 24. That's 7. I think that's right. All right, let me do some math here because I'm having a little bit of a brain fart. Yep, okay, good. All right, so 57 is not a perfect square. So we're going to get two irrational solutions. Again, irrational means that we're just going to get a square root. Okay, so we have one rational solution, we have imaginary solutions, and we have two rational solutions. Okay. All right, so graphically, this is what we're going to see. Okay, so if I graphed, let's say this guy. Okay, so let me pull up my calculator. Let's go to y equals. All right, so 2x squared plus 7x minus 3. Now, according to what we found, it says two irrational solutions. That means we're going to cross the x-axis, but it's not going to be a nice number. Boink. There he is. Here he is. Okay. Notice it's like 0.386. This guy here is negative 0.886. Not nice perfect squares. Two irrational solutions. Okay, but if I come up here, this guy, let's do this guy. 9x squared minus 12x plus 4. According to this, we're going to have one solution. Okay? And there he is. He happens to be rational. 2/3. Okay? All right. And let's try one more. Let's try this guy. X squared plus 5x plus 8. Okay, so notice he doesn't even like intersect the x-axis. There are no x-intercepts. So he's either totally above or totally below the x-axis. That's why he's imaginary, because he doesn't cross the x-axis. Okay, so that's what this is. So if you're positive, you're going to have two real solutions, whether it be rational or irrational, crosses the x-axis twice. Here, if it's equal to 0, you're going to have one solution, meaning it's like sitting on the x-axis. And then if it's negative, there aren't any solutions, real solutions. They're imaginary. The I thing comes up, but doesn't cross the x-axis. Okay? All right, so here, let's take a leap from here we found what type of solutions to, hey, we know the solutions. We're going to write the equation. And that's what we're going to do here. So when you write the equation, you're going to start by putting your answers, your solutions, into x minus a form. Okay? So it's kind of like going x minus the root, or setting it equal to 0 and solving kind of thing, but we're going to put it in this form. And the way we're going to do this is we're going to put it x equals our solution, and then we're going to work backwards. So we're going to either add or subtract it and bring it over to the other side. Or we're going to need to do some work because it's already a fraction, then we have to fix that, because we don't want to deal with fractions. We want to try and fix it so we don't have fractions in our answer. Okay? So I think the best way is by example. So let's take a look. We're going to find a polynomial equation with integer coefficients. That just means that all of our numbers are non-decimal, non-fractions, non-roots. It's just like 5, 10, negative 30 integers. Excuse me, I'm so sorry. For which the given numbers are solutions. All right, so here we have two solutions, 3 and negative 2. So we're going to go x equals 3, x equals negative 2. So we're kind of working backwards. So for us to happen, we're going to subtract the 3. We're going to add the 2. So now these are what we're going to use, x minus 3x plus 2. And we're going to put it in we're going to multiply them together. Okay, we're going to set that equal to 0. So we're kind of working backwards here. So we're going to multiply that. Now, pick your method. Box, split, distribute, FOIL. Doesn't matter to me. Pick one. Okay, so I'm going to do this one by FOIL. So I'm going to do x times x and get x squared, x times 2, negative 3 times x, negative 3 times 2. Equals 0. Combine things that are alike. There's your solution. Okay? All right, so again, we're just going to multiply them together. Again, pick your method, split, distribute, box, or FOIL. See, I call split, distribute, FOIL, or FOIL, split, distribute. So, all right, so let's go over here. We're going to go x equals 3 and x equals negative 2/5. Now, I don't know about you, but I have no desire to multiply anything that involves fractions. Okay, so I'm going to get rid of it. Now, the way we're going to do that is we're going to reverse the process. So I'm going to multiply by 5. So 5x equals negative 2, and then I'm going to add the 2. And that is always going to work. So multiply by the denominator, and then bring over the number. So here are your two binomials that we're going to multiply together to get our polynomial. So x minus 3, 5x plus 2. Okay, so a lot of you guys use box for factoring. So I'm going to use box here for this multiplying. So I'm going to draw my box. Okay, so when you multiply, I know we've done this. Okay, we're going to put the x and the minus 3 across one side, and then 5x plus 2 down the side. Okay, we're going to multiply, so 5x squared, so it's row times column. This times this. Okay, this. So negative 3 times 5 is negative 15x. Then you're going to switch to a different column. Okay, or a different row. So x is going to go like that. Okay, so x times 2, x, or negative 3 times 2. Okay, So we're going to get 5x squared, and we're going to be able to add the x's, so that's negative 13x minus 6. So there is your solution. Okay? All right, so let's do this one. All right, yes, radicals, we're going to be fine. Okay, so x equals 5 square roots of 7. X equals negative 5 square roots of 7. Okay, so we're going to have x minus 5 square roots of 7, x plus 5 square roots of 7, okay, equals 0, equals 0. Okay, so we're going to multiply those together. Pick your method. Okay. I'm going to do split with this one. Okay, one of these is plus. It's this one. Okay, so x times x is x squared plus 5 square roots of 7x minus 5 square roots of 7x minus, now when we multiply these two, we're going to get 25. And then square root of 7, square root of 7, square root of 49. Okay, it just so happens in this problem, these two are going to cancel each other out. And we're going to get x squared minus 25 times 7. 175. There we go. Okay? Yeah. Right? Yes. Had a little bit of a brain fart there. All right, let's try this last one. All right, so there are 3 numbers here. So we're actually going to go x equals negative 4, x equals 0, and x equals 1. Okay, add the 4, 0. Can't do much with that. So can we just say x equals 0? I'm just going to leave it as x equals 0, and this is x minus 1 equals 0. Now, I'm going to start with these two, and I'm going to write it as x times x plus 4 times x minus 1 is equal to 0. So I'm going to start with the x plus 4 and the x minus 1, and I'm going to FOIL those. So this x is just going to hang out. I'm going to combine my like terms. Okay, so I just multiplied the 2 binomials, the 2 termed guys, and now I'm going to distribute the x, add my exponents. And there we go. Okay, so if you have a 0, just call it, just use x and just leave that for the end, because that's going to be the simplest one. Okay, you can always check your solutions by putting, let's say, I got x squared minus x minus 6. I can always put 3 in for x and see if I get 0, and negative 2 in for x if I ever get 0. So you can always check your solutions. All right, let me know if you have any questions, guys. Please stay safe out there, and I'll talk to you again real soon.